network security, virtual private networks, encryption. We are going to cover symmetric and asymmetric encryption. Later on, we'll focus on hashing, which is a very important topic in VPNs as well. Let's start with encryption. We have two types of encryption solutions. It's symmetric and asymmetric encryption. Symmetric encryption, sometimes you can hear it's a shared key or a shared secret encryption. In this solution, you have a single key that will be used to encrypt and decrypt your data. When you look at this picture here, you will see that we have a message. Let me just change it here. You can see a message here. Hello world. Encrypt using a shared secret key. We'll get a ciphertext, something that nobody can recognize and understand. That's the idea for encryption. And then the other side will use the same secret key to decrypt that message and see hello world. We have a lot of, well, not a lot, but quite a lot encryption algorithms that we can use for symmetric encryption. Just show you that. Here we go. The most popular ones are DES, 3DES, and AES. 3DES and AES are really popular because they are combined and they are used in IPsec and all kind of VPNs. There is RC4 that can be seen in wireless networks. The advantage of symmetric encryption is that it is fast and it allows your traffic to be encrypted and decrypted on the fly. That's why we use that for VPNs, because it's really fast. The second one is asymmetric encryption. In this case, sometimes we call it public key cryptography. In this case, we have two keys. One key is used to encrypt your data, and second key is used to decrypt the message. Let's check it here. We are going to use one key to encrypt this message and another key to decrypt that message. Comparing to symmetric encryption, asymmetric is slower. That's why we do not use that for all our VPN traffic. In most cases, we use asymmetric encryption to exchange our keys that will be used for symmetric encryption. We are going to talk about PKI in a moment. For now, you have to remember that these two keys, sometimes they are called a public key and a private key. What we mean by that is that a public key is something that can be used by everybody. Everybody can see a public key. The advantage of that is that I can send my public key to you. You can encrypt a message using my public key. And who owns the private key? Well, that's me. It means that you cannot use the same public key to decrypt that message. I can do that because I have my private key, and of course private key, that's the name. I will never ever share it with anyone. And it can work both ways. I can encrypt something using a private key. What does it mean? Well, it means that everybody can decrypt that. And you all go, okay, why would you do that? That's not good. Well, sometimes it is. Why? Because it proves that I created this message. You were able to decrypt that message using my public key. It means that I had created that message. Let's talk about PKI, public key infrastructure. In cryptography, PKI is designed to manage, create, store, and revoke digital certificates, public keys. The idea for PKI is really simple. You have a server, a CA, something that certificate authority, somebody, something, a server, a service provider, a company, you will trust. Yeah, you say, well, because it was signed by Microsoft, I trust it. That's what we do every day, right? Microsoft, they introduced a feature like that many years ago. For instance, for drivers, they will warn you if this driver has not been certified. Why? Well, we trust Microsoft. Well, in most cases. We trust Microsoft, and we say, yeah, because it was signed by Microsoft, it's okay. The same idea is for PKI, public key infrastructure. When you receive a certificate from a trusted server, then everybody will trust it and will say, well, because this certificate was issued and signed by someone I trust as well, it means that you're okay. I can trust you. I can start, I don't know, a VPN connection or allow you to connect to my network because we trust that certificate authority. I am pretty sure you have seen a message like that when you browse the internet, Firefox, Internet Explorer, Chrome, all browsers will do that. In most cases, people just say, yeah, whatever, I don't know what's that, and it makes sense to read what your browser is trying to tell you at the moment. Let's check. Firefox wants to connect to 172.16.1.8, but we cannot confirm the connection is secure. And that is not a perfect sentence, because what do you mean it's not secure? It's not going to be encrypted? No. That's why we have some problems, or Firefox is not going to trust because we cannot verify the identity. Why? 172.16.1.8 is my server, my Microsoft server, and it generated its own certificate. It signed this certificate by itself. And of course Firefox is not going to trust a server like that. That is why you are going to get a message like that, and if you are okay with that, you can confirm and connect. Please note that Firefox will tell you that the connection to this website is secure. The main issue is that we cannot verify the certificate. This certificate was issued, was created by a device that we don't really trust, and that's not good, because the whole idea of a certificate is to get it from a place that we trust. If you go to Options in Firefox, this Certificates in Advanced, you will see Authorities. You have certificates on file that identify, yeah? Here is a list of companies that we trust. And of course, my server is not going to be on the list. You will find, for instance, GoDaddy, yeah? A well-known company, and they are allowed to issue certificates. If I had received a certificate from GoDaddy, I would have connected without a warning message in Firefox. The last picture I want to show you is how strong our encryption can be. Here it is DES and AES. AES 128, the most popular one, 256. In one of the videos where I connect to a firewall using L2TP, I use 256-bit key. That is really secure. Most people go for 128. If you connect to many websites, that's what you're going, and VPNs, that's what you're going to use. It is more than enough to make your connection very secure. We should avoid using DES. DES is not secure. 3DES is not bad. Here, it is on the list here. Still, 3DES is in most cases slower than AES and is not as secure as AES. Today, almost all devices and servers support AES. That's why, if possible, you should go for AES. In this video, we talked about encryption. I showed you the main difference between symmetric and asymmetric encryption, and we discussed a public key infrastructure. Thank you very much.